Greetings. Hello. Let's talk about the chain rule. Chain rule, also known as function of a function. It's also known as function of a function rule. Okay, what is the chain rule? It looks something like this. dy dx is equal to du dx multiplied by dy dx, or we can write it as dy dx multiplied by, I'll change that, du multiplied by du dx. So yeah, this, what you have here, is the chain rule. Yeah, sort of looks like a chain, right? Yeah, it's the chain rule or function of a function rule. It's a very useful tool when it comes to differentiation. Probably wondering why I'm introducing the chain rule. You'll see in a minute. Just now, let's say you were given a function. Let's say y is equal to 2x, function 1. Then you're required, okay, go ahead and differentiate this. If we differentiate this with respect to x, this will become dy dx is equal to, which is the same thing as y prime is equal to 2 multiplied by 1, which is just equals to 2. Someone is asking, how did you get that? Okay, let's go ahead. I skipped a step there, but let me go ahead and explain what I did. So dy dx, to differentiate this, I know that there is an invisible 1 there on a power. X is raised to the power of 1. So I know that I know. So there's a power 1. So to differentiate this, we'll use, or there's another rule of differentiation that I haven't taken you guys through, but it's a basic rule, which says if you have any variable raised to the power, and if you are differentiating that variable, you'll, let's say the rule says, for example, if you have y being equals to x raised to any power, n being any power, if you differentiate that, y prime, which is the same thing as dy dx, the differentiation of that means you multiply this whole function with the power n. So what that means is you drop the power n, bring it in front, multiply it with the entire function or by the entire function, and then subtract 1 from the power. Okay, so that's what the rule says. It's called the power rule. So that's what we did here. We applied the power rule. So this became 1, drop down the 1, and then multiply that by the entire function, which is 2x to the power 1, and subtract 1 from that power, minus 1, and that became 1. Okay, we can expand the bracket here. This becomes 1 times 2, that becomes 2, and then x raised to the power 1 minus 1. What is that? 1 minus 1 is 0. Therefore, this becomes anything raised to the power 0. We know that anything raised to the power 0 gives you 1. A to the power 0 gives you 1. So this is a law of indices that by now we know. So 2 multiplied by x to the power 0 is the same thing as 2 multiplied by 1, which gives us 2. So that's the power rule, and that's how we got to that value. So exactly, that was just straight shortcut. This is explaining how to do that very same thing. Alright, cool. So let's go ahead to where the chain rule comes into play. Alright. Okay, example 2. Say you were given a function y, the same function 2, but instead of x now we have x minus 2 raised to the power, not 2 because that will be easy for you to do, but raised to the power 100. What do you think we can do with this one? We can straight away apply the power rule, right? Yep, you are right. But then if we apply the power rule, then what do we do with this thing inside here? What do we do with that? Okay, this is where chain rule comes into play. Because if we apply power rule, this will look something like this. Okay. Okay, it will look, if we apply the power rule, this will look something like this. dy dx is equal to 2 multiplied by 100, x minus 2 raised to the power 100 minus 1. And this will give us 200 x minus 2 to the power 100 minus 1, that is to the power 99. Okay. Which will sort of, which will be correct. But, however, look at this. Which will actually, coincidentally, this will be correct. However, let's say instead of having x there, we had 2x minus 2 to the power 100. So I need you to see this. Alright, so if we differentiate this, it becomes, using the power rule, of course, it becomes 200 multiplied by 2x minus 2 to the power 99. However, this answer will be wrong, because what happens to that guy inside there? The reason why this one is correct, when we apply chain rule, you will see that the inside was differentiated. You have a function inside a function, so you need to differentiate that. So that's where chain rule comes in. All right. Okay. Yeah. So if we introduce chain rule, this would be multiply that with the derivative of what is inside. Derivative of x minus 2, that is just derivative of x, which is 1. So this whole answer here becomes 200 x minus 2 to the power 99. But if we introduce chain rule here, this becomes derivative of 2x minus 2, which is 2. So this becomes 400, 2x minus 2 to the power 99. Therefore, if you just use the power rule here on this expression, or on the second equation, which is this one here, when I say second, I'm referring to this one, you will get a different answer than when you would use chain rule. So that makes the power rule wrong. So the power rule will give you the wrong answer. So to differentiate this, there's need for another set of tool in our derivative or differentiation toolbox, or derivative toolbox, which we need. And that set of tools, or that tool needed is the chain rule, and which is what we are introducing you to in this video. So how does the chain rule look like? Where does it come from? Okay, as mentioned earlier, chain rule looks like this. dy dx, you were given a function, okay, with y and x as variable. So the chain rule will look like this. dy du multiplied by du dx. Okay, why do we have it? Where does it come from? The y has been discussed. Where does it come from? Well, good question. Well, if you had, say, okay, this is where it comes from. Where does this strange thing come from? This is where it comes from. Say you had dy dx. We know that dy dx is the same thing as dy dx multiplied by 1, right? Yeah, it's the same thing. It gives you the very same answer. Okay, what else do we know? We know that anything divided by anything will give you 1. What do I mean? What do I mean by that? This is what I mean. Say you decided to just say du, what is the answer of that? Du over du gives us 1. So we can decide to take this du over du, place it in there. That will still be mathematically correct. So we'll still be right. So we can rewrite that now as dy dx multiplied by du over du, which is starting to look more like what we have there. All we need to do here is just distribute or interchange just swap the positions of the denominators and the numerators. Just swap the position of those guys. This is what I mean. If we do that, bring this guy where dx was, this becomes dy over du multiplied by, we are actually swapping the position of the denominator, but it's actually the same thing. Either we can play with the numerators or the denominators, whichever one you prefer, it's still fine. So this becomes dy over du, and here we'll have du over dx. We've not changed anything. This is still the same thing. So this, what we have right here, is exactly as what you have there. It's exactly that. Chain rule. So let's see it in action, shall we? In the next video, come back and see chain rule in action. Yes.